Let's start it. Today we are going to discuss about the object class. Object class is a superclass of all the classes whatever we define in the Java. Like if we define a class student, it is automatically extended by the class object. It is a superclass of all the classes directly or indirectly. Directly, I mean to say that if I define a student class and we don't extend with any other class, it is directly extended by the object class. Let's take an example. Like if we have defined the student class and we have not extended any other classes for inheritance, this object class is directly extended by the Java. And if I say indirectly, I mean to say that suppose my class student is extending some other class university, and university is also some other classes. In this way, the student class is extending the object class indirectly. How it is possible? Let's see. Like we have created a class student which is extending the university class, and the university class is not extending any other class. It means that this university is directly extending the object class and my class student is indirectly extending the object class. That is why it is called the superclass of all the classes. And it is even if we don't use the word extends to extend the object class, we are extending the object class. It is also called as a root class of all the classes in the inheritance hierarchy. The object class contains different methods. Those methods are categorized into two different forms. Those two different forms are utility-based methods and another is a thread-based. The thread-based method like notify all, wait with the different overloaded functions will be discussed in more detail when we will study the thread class. But when we will explain all the methods, I will tell you that what are the basic functionality of those methods. So we will first focus on the utility-based methods. So what are the different utility-based methods? There are approximate 11 different methods including in these two categories. So we are going to discuss here. To remember what are the different methods are in an object class or in any other class in the Java API, we should always remember the return type, the name of the method, if any parameter is passed or any argument is passed in the function, plus the modifier or any access modifier is defined. All these will comprise called as a signature. So we should always remember the signature of the method for an exam. Now first we should understand what is in hash code. Before getting into the hash code, just I want to explain one more thing about the object class is why it is an implicitly extends, why all the classes extend implicitly the object class. Just to understand this, we should first know that Java do not support the multi-inheritance property. The multiple inheritance means that one class cannot extend more than one class. Like we can take an example, like student is a class, it is extending the university class. Now we cannot extend like putting a comma and extending another class X. So this is not permitted in the Java. It is called a multiple inheritance, which is not permitted in the Java. So I will add thing, multiple inheritance is not permitted. Now you can assume that in a student class, if I extend with some other class called X, now I cannot extend with objects. That is why just to extend two classes more than one, Java is implicitly added in such a way that if you create a class, automatically it extends the object class. The significance of extending is that all the method, whatever the method are available in the object class are also available in the extending class, right? Like if I remove this one, now I have a class student, implicitly my object class is available with the student class. When I say inheritance hierarchy, I mean to say that classes will use the extended behavior and the object will exhibit the behavior of the object class. What I mean to say that the object of the student class will exhibit the behavior of the superclass and the class will inherit the properties from the object class. There are 2 points, again I am repeating. First one is the object of the student class will exhibit the behavior of the superclass object, which is implicitly extended by the student class. And the second thing is the student class will extend the inheritance property from the object class. Okay, now we'll come back to the different functions available in the object class. First we are going to discuss the utility based methods. The first method is a hash code. This hash code is, first we should know what is a hash code. In terms of data structures or algorithm, the hash code is a unique distinct value which is used in hash tables. Okay, when we store some data, we need a different value as a key to store that object or a value, object or a data. So those values are actually a hash code. Okay, so from that concept of data structure or algorithm, this hash code comes into the picture. And there is a misconception about the hash code is that in Java, hash code represent the memory address of the objects. Just I want to tell you that in Java we do not use the address. We cannot disclose the address. There is no pointer. In Java there is no pointer. Just because of that we cannot access the memory address of a object. Now what happens? This hash code returns an integer value which is mapped in such a way that which is equivalent to the address. It means that the address of the object is converted in some integer and that integer will be returned as a hash code, which is not exactly the address of the or memory address of the object. Okay, now return type is int. It means that it will return the integer part. It will return an integer and it will be the hash code value. In Java, hash codes are very much important in terms of hash table or in terms of hash maps. These two classes in Java are the part of the collections. These two classes are a part of the collection framework. The hash code is used in these two classes because the hash maps contain a key value pair where the key can be a hash code, and in a hash table, again, it's a legacy class. It is also used as a key value pair. So this is the legacy class in the collection framework. This is the new class which can be used as a key value pair. Similarly, if another class of the collection framework is hash set, even in the hash set, the hash code is used for making as a unique identifier. As I said, hash code is a unique and distinct value of an object. Now in terms of Java, this hash code is unique distinct value of an object. Now this value means that suppose we have a different objects, all the objects hash code values are different because those objects are different. Even for a single class student, we have two objects or three objects, S1, S2 and S3. The hash code value of these S1, S2 and S3 objects are unique and distinct. That differentiate the identity of an object. That makes this hash code makes the object identity different. Okay, now this hash code we can overwrite. As this hash code and all other different methods are a part of the object class, and my student class is extending the object class, so that it means I can override this method and give a different implementation if needed. Okay, if I implement or if I extend the method, if I override the method in my student class, how I can write to override the method? Now student object, because hash code belongs to an object, unique value of an object. In my student class, what should be the unique value of an object? Now because I am overriding the student class, I can also say that the hash code can be a roll number. It means that I can return the roll number of a student, which will always be a unique, and it can represent to the value of a unique value of a hash code. This is one of the basic implementation, or you can say overridden implementation of an object class method hash code in my class student. Similarly, based on your requirement, based on the things needed, we can write the different implementation hash code. In addition to this, I want to say that hash code represents the unique value, unique representation of an object, and it is basically used when we do the equality check in the two different objects or inequality check in the two different objects. Now we move to the next function, which is equal. The next method in the object class is equals. The equal method checks the equality of two different objects. Suppose it gives a very generic implementation in the object class. It means that if you have called the equal method with the help of s1 dot o1, I'll just tell you. Now the object which is calling equal method is comparing with the object which is passed. Now we are comparing the s1 with the s2. It will compare the state of the, it will compare the memory locations. By default implementation is a memory location, so it will compare the memory location of the two different objects. It means that it will return boolean is equal to true, or the return type is boolean. It means that it will return the value true when the two objects point to the same memory location. Let's take an example to understand this. Now S1 is pointing to the object memory location, this one, and even S2, S3 is also pointing to this location, and S2 is pointing to the different memory location, and all these objects are S1, S2, 3 are the objects of the student class. Okay, when I call the method of equal with S1 dot equals S2, it will check the memory location because I have not overridden the equal method in my student class. So it also means that I have not overridden. It will call the superclass object class equals method, and the object class equal method, the default implementation says that it will check the memory location. Now with this example, S1 equal S2 will return me the false because both are pointing to different memory location, so it will give me false. Now if I execute this equal method again with different objects, S1 dot equals S3. Now S1 and S2, S3 are pointing to same memory location. It means that now they will say that the return type of the function is true. So this is a very simple method, but if to extend this method means if we want to override this method, and why we need to override. The need to override this method in the student class is that if the programmer wants the equality conditions based on its own, like in a student, two students are only equal when they have the same name, when they have the same number, when they are in the same class, or these are the, let's take three examples. The two students are equal when they have the same name, this is a hypothetical assumption that if the two students can only be equal with they have the same name, they have the same marks, and they have the same class or same course. I am not taking as a roll number because roll number cannot be same. In that way, the two students cannot be equal. This is a hypothetical assumptions. If we have this scenario that when these threes are equal, the two students can be equal. In that condition, in that scenarios, we need to override the equal method because the object class is giving a different implementation. Now we need to override that implementation from the object class. Again, object class is a parent class is on the top. Now your student class is a child class is in the below one, and there is a relationship between automatically or implicit relationship between the student class and the object class. Okay, now if you are not overriding the equal method in the student class, what does it mean? You are using the equal method of the object class, and what the object class says, that means equals, it behaves in such a way that it will check the memory location of the two different objects what we have done. Now if we need a different implementation, we need to override. Now how to override? Let's take a simple code. We are not getting into the what double equals or equals do. Just double equals we'll see that double equals is checking that both are equals or not. Now in this overridden equal method, what I have done, because it's a part of the student class and the student object will call the equal method by by the feature of inheritance, now this overridden method will be called whenever we call the student equal. Okay. Now with the equal method, I am passing the S2, I am comparing Sx. Now when I call S1 dot equal with S3, this S3 will go to the Sx. Now Sx name should be equal to the this dot name. So what is this? This is an implicit object. Whatever the object is calling, like S1, this will represent the S1. Similarly, if you call S2 dot equals, this S will represent S2. Okay. Now this represent S1 means that S1 names should be equal to S3 name. Okay, when all these three conditions are true, in that scenario we can say that the S1 is equivalent to S3. This is our own condition. Now just to this condition is true, we need to put in a condition block. Like we can write if this and you can write if this name is equivalent to Sx names and these marks and these scores are equals or same, then we can say that it should return true if this three condition together returns the true, that means are equals, then we can return the true, otherwise it is false. Either of condition doesn't match, then false. That means the student 1 and S3 both are having the same mark, same name and same course. So this is the overridden part of the equal method. Okay, third method in the object class is a toString method, whose return type is a string. The toString method is returns the string representation of the object. Now the return type of the toString is a string, means that it is giving me the description in a string format, whatever the object contains. Now similarly, like the above two methods, if we have not overridden the method in our class, what it will return? Now the S1 is an object of the string class. If we write the object in a system.out.println S1, it will automatically call the toString method. And the default implementation of the toString method, which is given in the object class, is a hash code in hexadecimal format, including the class name. You will see the class name, whatever the class objects is, like here it is a student, the student at the rate hexadecimal some number as a which is a hash code, it will return when we write the S1. Now it is not that meaningful. It means that we need to override the toString functions in our class. We can also override just like how we override the equals and hash code. I am considering in my student class I have two instance variable and which I want to represent as a string representation for the object. Like if I have a student S1 and whose name is suppose Amit and his roll number is 20, and whenever I write the object in SOP and the toString method will be called, I will show that the S1 is actually the string representation of S1 will be the Amit and the roll number. You can add more variables for the string representation as you need it. In our example, just we need to represent S1, just the name and the roll number, that return this name will be printed as a string name, and the name is actual name Amit, and then roll number it will print it as a roll number equal and the roll number of the Amit 20, like. So this will be the string representation, and it completely depends on you what kind of representation you want to see. The significance of the toString method is when we debug the code. Like whenever we want to see that in between the 100,000 lines of a code, what my object S1 or S2 is representing, either it is representing null or whatever the value it's containing, it will help you in debugging. Now, next method in the string class is get class. The fourth method in the object class is a get class. The get class method returns the runtime class of the object, which is represented by the java.lang.class. Here C is a capital because this class is also a class. First we will see that what this class is. Class is a very important class in Java API. It is contained in the lang package. Package means that package is like a directory in the DOS operating system, or you can say that it is a folder in the window directory. Packages provide namespace, and we will learn the packages in detail in some other lectures. Just for understanding, package provides namespace, means that you can have two different classes having the same name in different packages. Like you in the C drive in your window operating system, in C drive, if you want to save two different files with the same name in the same directory, it is not possible. You need to create two different folders. That means both the files X are in the different folders, A or B folder. It means that this A and B folders will provide the namespace to the X file. Similarly, in Java, the folders behaviors are reflected by the packages. The packages are just like a container and provide the namespace. And the class object class which we are discussing today here is also a part of the lang packages. Lang package means a language. Language package is an implicit package which is imported implicitly in the Java. Whenever you use any class or interfaces in Java which belongs to lang package, you do not need to import. Otherwise, other packages need to be imported before using that. Okay, so we will discuss in some other lectures. Now, this get class will return me the runtime class of an object. So, what kind of object? This one. Suppose I have a string class and I am using the string object s1 dot get class. It will give me the object of type class. This is a string, and this is a way to create the strings. Why I am writing object O? Because object O is a superclass of all the classes, and because of the behavior of dynamic method polymorphism, runtime polymorphism, the subclass string objects can be stored in the superclass reference variable. Okay. Now, with this O, which contains the string hello, I am calling the get class method. This get class method is returning me the object of type class. So that is why I'm storing in this. Now this class, this class get class method and this class is very important because it will give you the information about the metadata of the class. The metadata means the internal details. Now if I call the system.out.println and in that if I call the c.getName, it will give me the name of the class. The result will be java.lang.string because the string, it will not give me only string, it will give me the fully qualified name of the class, which is java.lang.string. Now you can see that I am having a string object. Okay, I can also take the string O, no problem with that. The O I am calling the get class method. Now this get class method is returning me an object of type class, and that with the help of this class I can call the method. There are various methods are there. c.getName will give me the class name. Now I'll tell you one thing which is not a part of the lecture but it's very important. This class and this get class is basically used with the reflection. The reflection is another Java APIs, and it's very important to understand what are the different variables, methods in a class when we have only the object. It means that suppose I have an object and I want to get the internal details about the different methods and different variables or what is the class name, where it belongs, I can fetch with the help of reflection. And I'll give you an example. You have used the IDE like an Eclipse or a NetBeans. The Eclipse is more important. When you write an object dot and object dot, automatically a list of the functions and variables comes in the picture and you can select out of them. This is the property of any IDE. IDE means integrated development environment. Eclipse is most popularly used in the industry. Now when I write S1 and dot in any IDE, it will give me the list of functions. So how this functions comes in automatically just because of reflection. Reflection uses this classes. This class knows the metadata about the class. Once you have an object, you can call like this and you can have this method. So this is the wonderful application of a class method. Now next we have another method called clone. One thing I want to add, by looking into the signature, the modifier used in this method is a final. The final means that earlier all the three methods equals to strings and hash code we have overridden in my student class, but it is a final method. We cannot overwrite. Final says that this method is final. It doesn't need any other new implementation, and you cannot, or the user class cannot override. In our student class, even we have an object superclass and we cannot override the get class. Whatever the implementation is given by the object class, we need to follow that. Okay, the next method in the object class is a clone. The clone method is actually is equivalent to the copy constructor. You have studied copy constructor in the C++. Copy constructor creates exact replica of your object. Java says that Java does not say Java says that we should use a clone method instead of a copy constructor, because the method clone method will help you in creating or exact replica of the object. Now when you call the clone method, or when you create a replica of any object, it can throw an exception. That is why they have added one more exception called clone not supported exception. We will discuss these exceptions and clone method in the next lecture, which is a cloning, then where we learn two different kinds of cloning, deep cloning and shallow cloning. So I will discuss in detail in the next lecture. Now what the clone is doing, actually it's creating a replica. Let's see what exactly the replica is. Okay, now suppose we have a student class and the S1 is the object of the student class. The student class contains three different variables: instance variable, name, age and roll number. Now, and having some values like Amit, 20 year of age, roll number 1. So this is the state of an object. Now either we can use the copy constructor or a clone. Clone is a better approach. Now clone, if we clone this object, automatically another replica of this object, exact replica of this object will be created. Now what I have done here is I have called the s1.clone. That means that I want to create an exact replica of this object, means this thing. Now what happened when we call the clone method, exact replica will be called. The same value Amit 20 and 1 will be created, and it will point to S2. That means exact replica of this will be created in S2. And as the return type of the clone method is an object, it means that it will give me the object kind of variables. Now we need to typecast to the student, because we are creating an object of the clone method. And why it is returning the object? Because of the dynamic method polymorphism. This reference can hold the object of any class. Suppose we have n number of classes. You can create n number of classes in Java. One is university, one is student, one is A, B, C. But you don't know what is a superclass. An object class is the superclass of all the classes. It's better to catch the objects of A, B, C, university, student in the reference variable of an object. That means object can point to all the classes. That is why the return type of this function is an object. Okay, and while creating a clone and you are not using the clonable interface, which will be discussed in the next lecture, then it can throw the runtime exception. Okay, next method is a finalize method. Why they are protected, we will discuss when we understand the concept of package. Then we can know that we should know that why this clone is protected. Okay, now finalize method is used with the garbage collectors. Let's understand a brief understanding of the garbage collector, because it's a complete different topic. The garbage collector is a collector which collect the garbages. So what is a garbage in Java? So we say that dangling pointer in C++, dangling pointer which are not pointing to anyone, we can say that unreachable objects are the garbage. What is an unreachable object? Suppose we have an object pointing by the reference variable sx. Now in the next line you say that sx point to some other object which is sb by writing sx is equal to sb. Now what will happen after this line of code? It will point to this and this will be lost. Now a pointer or a reference variable pointing to this object will be lost. Now this is eligible for garbage collection. So unreachable object. In short, I'm writing garbage collector, eligible for garbage collector. Why? Because it's unreachable. It's an unreachable object. Okay, so basic concept of garbage collector. Garbage collector collects the unreachable objects and clean the memory area so that it can be used for the new objects. Okay, we will discuss this in separate section because garbage collector is a different topic. Now this finalize method is used with the garbage collector. Let's take an analogy. Suppose in the morning your maid come to the home and it cleans all the things. Okay, one day maid is on leave and then your mother is cleaning all the stuff. What happens? Before cleaning the thing, your mother asks, this is a waste paper, can you check this is valuable to you or should I keep in the garbage? Okay, now before putting that piece of paper which is relevant to you into the waste or a garbage, your mother asks for, can you check this is relevant to you or should I put in a garbage? So garbage collector work is to put into the garbage, but finalize method will tell you that if you want to do any kind of process to that object before putting that into the garbage collector. What I'm saying is here, before this unreachable object to be a part of garbage collector to clean this memory area and use for another object, it can be resurrect or it can be bring back into the action by using the finalize method, which also means that this finalize method will be called before cleaning the area by the garbage collector. I'm also saying that garbage collector before cleaning the memory area will ask you want to do something and that something can only be done in the finalize method. And as it is a part of object and objects are cleaning, that objects you can do n number of things, and those n number of things are a part of a garbage collection. We can discuss, like we can clean, we can remove the resources, we can remove the connections. Okay, we can clean the connections. Okay, so these kind of things will be done. Now the finalize method can only be called once for an object. The finalize method can only be called once or for an object even that object is eligible for garbage collection n number of times. It means that it is eligible for garbage collection, you bring back with different ways, and then after that it is again become eligible, but you can only call finalize method. This is a very important question in the interviews, that what is a finalize method. Okay, so you should understand this concept. Now this finalize method can throw an exception. This throwable is a super class of all the exception, then which we will understand, we will learn in the exception topic, exception classes. Now all these 6 methods are utility based methods which we have learned. Now remaining 5 other methods belongs to the thread classes. So we have two different two methods are in the thread category, but they are overloaded. Rather I should say 3. First one is a wait, which is an overloaded method. We have 3 different overloaded methods. Second is a notify, and another one is a notify all. So in total there are 5 different methods. So this is the first method. It is a part of an object class, but still we are saying that they belongs to the category of thread. So this is very important understanding why they are in the, if they are belongs to the thread category and still they are in the object class. So those things will be explained in the thread class, but just I will put some highlights or limelight to understand high level overview of the wait method. Now we have another overloaded method with public final void wait long L. Okay, again all these methods belongs to the threads. Belongs to the threads means that they are used while using the thread, but still part of an object. Why? First, thread. What is a thread? Threads is a concept. Thread is a concept you have used in the operating system. So those concepts we have replicated in the Java. In the operating system, you know that we have a critical section. The critical section is a very important piece of the code where multiple processes, multiple threads parallelly, simultaneously, concurrently access. And if the multiple threads simultaneously access, the result of that code can be inconsistency in the data. Like suppose in this room we have a data X, and this parallelly 10 people are coming and using that, modifying and updating, the value of this X variables can be changed, and by changing by one person, and another person can still use that old value. So this will make the integrity lost about the data. So this is an important concept we have already learned in operating system. So similarly in Java, what happens? We rectify, we use this concept of locking on a object. So object in the lock is always acquired on an object. If we have a lock on an object, it means that whatever the method we applied should be on an object. That is why these methods are a part of an object. Okay, so we acquire the lock on an object. It means that whenever one thread is acquired a lock on an object, other thread will wait to enter into that lock, or you can say enter into that critical section. We can implement with the help of synchronized function. We will discuss in detail. So just for the understanding, you understand that locks acquire on an object. Once a thread acquire a lock on an object, other threads will wait for that. Now this wait is similar, is a similar thing. Now suppose one thread acquire a lock on an object, and other thread comes, it can wait for a long. So that means it can wait outside, and once the running thread execute or complete or finishes this execution, it can notify that thread. This is a notify function. Okay, now we assume that one thread acquires a lock, executing the piece of code, multiple threads comes and wait. Okay, and I want to notify all of the threads in a one go, then we can use a notify all. So all of the threads which are waiting outside can be notified, and then can acquire the lock based on some scheduling algorithm. Okay, now different overloaded wait method means that one thread acquiring a lock, and other thread can wait for some time, or this is a more peculiar specific time. This int is a nanosecond, this is a millisecond. So you can have millisecond or millisecond and plus nanosecond. So this is these two overloaded methods specify the time bound that it will wait for that much, then and then after the completion of this time, they can come out, and then they can execute some other task. And one thing I have not written, that this method, this wait method will can throw the interrupted exception. All the three wait methods also throw an exception called an interrupted exception. What exactly exceptions are? Because exceptions are a different topic, we will understand, we will learn in different lectures. Exceptions are the abnormal behavior of the code. Whenever what happens, anything like divided by zeros, or you go out of the index of the bound, the exceptions throws. Similarly, we have interrupted exceptions is with the wait method. What happens? Suppose a thread is uh, having a lock on the object and it is executing the piece of code. In that scenario, in that conditions, if other thread interrupt the running thread which is acquiring a lock, that it can throw a interrupt exception. So these kind of exceptions we will discuss in thread section, where you will have a complete understanding of the exceptions and thread and different things. So for this thread kind of category of methods in the object class, 5 different methods, and this is very important to understand why these methods still are with the object class, because objects contain, or threads contain, a lock on objects, and it reflects that behavior. So this is all about the object class. Thank you for watching this video.